All right, so we're back talking about section 2.3, the function section. In the last video, we finished up, we were talking about domain and range. What the domain and range is of a function, and also how can you tell if something is a function. So we'll continue on. This is the last thing you saw in the last video. And we talked about how the square root, it was a special case where not just anything goes for x. You can't plug in anything you want here. Domain means what can you plug in for x and get a real answer for y. So we have to plug in things that keep this actually 0 or larger. So we're really saying what makes x plus 3 stay greater than or equal to 0. Anytime you have a radical, the square root of a negative number makes it imaginary, and we aren't allowed to have the imaginaries for our graphing world right now. So we say it's not in the domain. To solve that, we throw the 3 across the line. So the domain would have to be greater than or equal to negative 3, and that's what we noted it as earlier. Now, what about the range? What is the range of this? What is its lowest y value that you can achieve? And you might see it visually here. It starts at y is 0. This is x is negative 3, but the y value there is at 0. So for the range, that means y, it dips down at 0 and then it gets up, up, up. It's not going up very fast because this little arc is a slow moving curve, a very steep curve, but it is eventually going to positive infinity. So we say the range has a low value of 0 and then on to infinity. Okay, let's try another. I'll have you do this as a you try. What if we had y equals square root of x minus 3? Find the domain and range of this function. And again, always pause the video and try that. Think about it. You may want to put it in your graphing calculator and just look at it. It's already solved for y, so you may see in your graphing calculator that it has, maybe this surprises you, it's shifted over positive 3. And this is actually going to be a rule for us when we have something added or subtracted that's in the action of the x. It's under the radical with it or in a parenthesis, somehow attached to the action of the x. It shifts it the opposite than what you might think. So even though it says minus 3, it's moved it over positive 3. Now we can surely see that with some t-table points, and really that's what we're supposed to be doing in section 2.3. We have not learned that the patterns of all the different graphs yet. We are just like trying to find some t-table points and figure out what it looks like. So the first thing you can plug in, you might try to plug in 0. 0 minus 3 would be the square root of negative 3. The square root of a negative is imaginary, so we're not allowed to have imaginaries, so that's not in the domain. If we try 1 minus 3, I'm still in the negatives. Even at 2, still in the negatives. It's not till you get to x is 3 before you get a real answer for y. So the domain starts at 3. 3 minus 3 is 0. The square root of 0 is real. So that is the first number in the domain, 3. And also you can see the graph starts at 3 and it goes on over. You can plug in x is 4. 4 minus 3 is 1. The square root of 1 is 1. So over 4 should be up 1. You could plug in any fraction, anything greater than 3 is allowed. So we would say the domain, bracket, 3, and anything larger than that. Now how about the range? The range is the lowest y value. This y value, y-axis perspective, that's 0 for y. And then it goes up to infinity. So the range would be 0, like so. And these are functions. You can draw a vertical line. It only hits it once. So we could also say this is f of x equals function notation. Okay, let's try another one. Let's say we have f of x or y equals the square root of 2x minus 1. This one's a little tougher. I'm going to have a fraction to deal with actually for this. How can we figure out where this graph starts? All right, so think about that. And again, feel free to use your graphing calculator to look at it visually. But the first thing you can plug in is always whatever makes the stuff under the radical equal 0. You're trying to keep this positive. So actually, I should say it has to be greater than or equal to 0. That's what the domain will be, is whatever makes the stuff under the radical stay greater than or equal to 0. So we can solve that by throwing the 1 across the line, divide by 2, and it actually starts at a fraction this time. So at 1/2, at x is 1/2, so let's say if that's 1 and 2, it starts at a half, and you've got an arc like that. So that will be the domain value. The first thing you can plug in for x is at a half. The range, the y value, we haven't done any where I've had the range changed. We need to do that next, don't we? Like so. All right, so let's do one where the range is changed. Let's say we had f of x equals the square root of x plus 2, like that. The 2's not under the radical with it. Now I want you to think about domain and range. What can you plug in for x now and get a real answer for y? Okay, so we can plug in 0. Square root of 0 is 0. 0 plus 2 is 2. So I can plug in 0. I can plug in 1. Square root of 1 is 1. 1 plus 2 is 3. I can plug in 2, but I won't get a nice, neat answer. It'll be the square root of 2 plus 2, which would be about 3 point something. You could get that on your calculator. It wouldn't be a nice, neat, perfect answer. The next nice answer would be 4. Square root of 4 is 2. 2 plus 2 is 4. And so what happens this time, if you plot these points, you've got 0, 2, over 1, up 3. Let's do 1, 2, 3, 4, and up 4. Look at this arc. It's floated up in the air. So whenever the addition or subtraction's on the end of the graph, it actually moves the graph up and down. And as you would expect, it says plus 2 and it moved it up 2. So if we have an independent add or subtract on any of our basic functions, it shifts the graph vertically now. So this one does change the range. The domain starts at 0. And we can see that's the first number we could plug in for x and get a real answer. You could not plug in a negative for x. It would make that imaginary immediately. So 0 is the first okay x value. But the range was moved up 2 places. It's the first answer we got for y. Plus looking at the picture, it starts vertically, you know, for the range. It starts at a value of 2 and then it goes up higher. So we would say the range is 2 and up, like so. All right, let's talk about the parabola. Let's talk about this graph. Y equals x squared. Again, try to plot some points or use your graphing calculator to see what it looks like. We can plug in x is 0. 0 squared is 0. I can plug in x is 1. 1 squared is y is 1. If I plug in negative 1 and squared, it's also 1. So let's talk about that. The y value repeated, but it's still a function. As long as the x does not repeat, we can call these functions. So again, the y can repeat. It won't be a one-to-one function, but it is a regular function that we're studying in this section. If I plug in 2, 2 squared is 4. If I plug in negative 2, negative 2 squared is 4. So plotting a few of those points on your graph, over 2, up 4, back 2, up 4. You get this U shape. That's called a parabola shape. A parabola is a function, or an upright parabola, our function parabola that we see here. If we draw a vertical line, nothing is repeated, so it passes the vertical line test. Also, looking at some T-table example points, we can see there's something up on the y side. The y side is repeating, but the x does not, so it passes the function test. We would say the domain is negative infinity to positive infinity. And the range, though, you can't get a negative answer because we're squaring the x's. You know, the input independent variable gets squared. So the y over here that's depending on what happens there, the y value is always coming out positive. So you cannot get a negative answer out of this. The range starts at 0 and then goes up. Also, you can see it visually. 0 is its low point and then it goes to infinity. All right, what if we had y equals x squared plus 3? So look at that graph. Again, take some time to use your graphing calculator if you want, or plot some points. And what you should discover is this parabola has been moved up 3 places. So you can input anything for x, and you'll get an answer over here for y. So the input values are fine. You can input anything. Also, can you see in the picture that the wideness is without bound? It goes left and right, opening up with no restrictions. That means anything goes for plugging in for x. You know, the radical was kind of the special case, that last example. With radicals, we have the imaginaries, so we can't have an imaginary, but no problem here, no problem here. But the range gets affected because the lowest the graph goes is at 3. 3 and then infinity, like so. And again, it is a function. All right. The next thing I'd like to mention in your note packet, so enough about that domain and range for a minute or two, we'll come back to that of course, is the function notation. So once we, and again I'm kind of second page down, or just follow along with this. Let's say we had a function f of x equals 2x plus 5. We could answer question, this is what you'll see in your homework, besides domain and range and whether things are functions, we're going to use the function notation. If we are listing a function, f of x equals, and it says find f of 2, that means when x is 2, what is y? So we're replacing x with 2, so it means make this x a 2, and then work it out. That would be 4 plus 5, or 9. The answer to that would be 9. It actually, if we were making a t-table, that would be plugging in for x, and the output would be y. It makes our x, y values, basically. This function is just a different notation for what we were doing before. It also asks you to find f of 4. F of 4 means make x 4. So 2 times 4 plus 5 is 8 plus 5, or 13 is the answer there. Next, you're asked to find f of x plus 4. All right, now we've got some algebra to plug in. So not just a number, but some algebra. So whatever's in this parenthesis is what we input for x. And then if it's just a number, we work it out. It's like a y value. But here we'll have a little algebra. So always simplify your algebra as much as possible. So distribute and combine any like terms. And that would be our answer for that. What if it said find f of x plus h? What does that mean? Again, whatever's in this parenthesis, we plug it in for the x. So it means plug in x plus h where the x was. And then simplify as much as you know to simplify. So here we can distribute, and then that's all we can do there. And that would be our answer. Next example, we've got a new function. Let's say we have a g of x equals 3x squared minus 2x. Okay, again, I'm going to ask you to pause the video and try these 3 problems. So the first one says do -1 for your x's. Carefully plugging those in for each x, and then use your calculator if you like. That'll be 3 times 1 or 5 for that final answer. Next, we're plugging in 3 for x. So plugging in 3 times 3 squared minus 2 times 3. These are workable. And again, you can feel free to use your calculator to do this. 21. And then this last one, back to the algebra, plug in -x for the x's. So how do we do that? Make each x a -x, and then do some algebra to it. Negative squared means that's going to be positive. The negative squared makes that positive, and this negative times negative makes that positive. So that would be our answer. And then you have one more on that page. Another function, kind of just messing with the different namings of it. Now we're naming one h of x. And we're doing absolute value of 2 minus x. And I asked you to find h of 7. So we plug in 7 for the x. 2 minus 7, take the absolute value. absolute value of -5, or an answer of +5. All right, so that's how we use the function notation. And I'll come back into the video and we'll finish up section 2-3.